Okay, everyone, let's get rolling here. Good afternoon and welcome to 5 Principles of the Modern Data Platform. As Amanda mentioned, I am Stephen Giles. I'll be your presenter today. I'm the Director of Data Infrastructure here at Dimensional Strategies. Just a quick word for those of you who may not be familiar with Dimensional Strategies or DSI. We are a company that is wholly dedicated to data. We have been doing this for 20 years. We started life as a Cognos shop, but about 10 years ago, we decided to make the shift entirely to the Microsoft platform. And we are currently a Microsoft Gold partner in data platform, data analytics, cloud application development. And this really puts us in the top 1% of Microsoft partners globally. And really, we do all things to do with data, and that's all we do, and we do it very well. So what we're going to talk about today is something that I have been thinking about a lot and something that I've been having a lot of conversations with my customers about, and that's this concept of the modern data platform. So I'm going to start by defining what I mean by modern data platform, and then we're going to drill deeper into 5 principles that really make up the modern data platform, and those are security and compliance, platform, performance, functionality, and extensibility. And I'm going to explain each of these and look at some specific examples. Now, we are going to focus mostly on Microsoft SQL Server. As I mentioned, we are a Microsoft shop. Some of the information I'm going to give about the data platform is really a little more generic than SQL, but the examples we're going to pull from are coming from SQL Server. Now, for this session as well, I am not going to go really deeply technical into any of these. I do a workshop, a half-day workshop. We're doing one sometime in January. I'm not sure if it's on the website yet, but in that workshop, I do actually go into these tools, show how they work. But in this case, I really want to talk about what and why you should care. And that's really my goal for the next hour. As Amanda mentioned, I've got some spots where I'm going to stop and ask for questions. If you have any questions at all, throw them in the chat window, and I promise we'll get to all of them before we're done. So let's start by the definition of the modern data platform. Now, you've probably heard all kinds of thoughts on data. So data is the new oil. Those organizations that are not deep into AI and machine learning will fall behind their competitors. All you hear, if you read the business press and HBR, you're seeing all kinds of articles about this. But most of you are not in the data processing business. Most of you are in something else, manufacturing or healthcare or financial services. But there's no denying that data becomes important. And to get the use out of data, which I think is more important than the data itself, you need to have a data platform. And that platform has to sit on 3 key pillars. The first is security. If the Equifax breach and any of the other high-profile breaches that we've had in the last couple of years have shown data is an asset, data is also a potential point of risk. And you mitigate that risk by having a proper, secure infrastructure to store your data. And that security cannot be localized to a database or a file share, but it has to be something that you think of across your platform. The second pillar is performance. The data systems must be available whenever the users need them. They have to be performant so that if users are using the system, they get the data quickly, they don't have to wait. Because really, if the performance isn't there, then the data systems will not be used, and my users will start coming up with their own novel and creative ways to store data, usually involving spreadsheets. And that takes away from the value of the platform. The third piece is functionality. Now, this is pillar I've been going back and forth on naming this. This is my current favorite. And functionality is really, this data platform must serve a business need. We are not going to store data for the sake of storing data. We may be storing data for compliance reasons. So if we're in healthcare and we have to store patient records for X number of years, then that's functionality. But what's more important is not the data, but the information that can be gleaned from the data. So can the data stored within my mature data platform get the right information to the right people in the right format at the right time, so that they can perform, so that they can make the right decision and they can impact positively my organization. So that really, functionality comes into that. So let's drill a little deeper into these three pillars. There's a number of pieces that make up the security pillar, everything from how we authenticate to the data platform, to how do I detect threats and intrusion, how do I monitor activity, and do I meet compliance? And really, single sign-on is very important, I think. One of the lessons of the past is really that users will not work with systems where everything they have to go into has a separate password. For two reasons. One, it just opens a huge security hole, because if the average user has to store multiple passwords in their head, they're either going to use ABC123 for everything, or they're going to write it in sticky notes and stick it to their monitor. So you want to have that single sign-on where I log in once, and then my identity follows me throughout the data platform. Things like data masking and row-level security, they allow me to control not only access to the data platform itself, but to specific records within the platform. Encryption is key. As we've seen from all of these breaches and data thefts, I need to protect my data at rest. I need to protect my really sensitive data at all times, and so encryption becomes a big part of that. Compliance is a big piece too, that there are a lot of security requirements in compliance, particularly if you're looking at things like PCI, where all the rules around the storing and access of credit cards is all security based. So any good platform has to be universally secure, and secure by design, not as an afterthought. There's a number of pieces that fall into the performance bucket. So high availability and disaster recovery. My database, or my data platform, if it becomes mission critical to my business, must be available whenever users need it. So all systems should have some form of disaster recovery. And for anything that is deemed mission critical, there should also be a high availability solution. So if a individual machine or a individual component on a machine fails, how do I keep working? And that's where high availability and disaster recovery comes into play. The second piece of performance is elastic scale. Do I have enough resources to do the things that I need to do to be performant at any given time? Now, I've added the word elastic here because one of the biggest changes, particularly with the advent of the cloud as part of the calculus of the modern data platform, is that scale is not only scale up. You can also scale back down. So if you think of the ebb and flow of your business, you have peaks of high activity and you have valleys of low activity. So you may have a fairly steady activity level that kind of goes up during the day and down at night, and then it spikes at month end, and then it spikes really large at quarter end, and then it spikes really, really large at year end. So do you need then to have a platform that's always ready to handle the full capacity of the year-end production? Or do I have a situation where when I get into my peaks, I can add more resources, and as I come out of my peaks, I can take some of those resources away. I can have more efficient costs, but I can still meet the performance SLAs back to my business. I don't want to underpower year end, but I also don't want to run all year as if it was year end, because then I'm just way over provisioning my system. Third piece that falls under performance is in memory. This is something that is becoming prevalent across all data platforms. More and more we are using in-memory systems for data. And there's a couple reasons for this. One, RAM is a lot cheaper than it used to be. Back when I started, when it was $100 a megabyte, you flushed as much to disk as you could. But disk and disk I/O is the slow link in the performance chain when it comes to a database. So the more I can run in memory, the more performant that I can be, and the more things that I can do. So we're going to see some examples later on where we may need to do processing in memory that we could never do if we had to go back to the disk. And we'll get to that when we get to the section. And the final part is platform. This has to be performant wherever I choose to put it, whether it's in a VM or on bare metal, whether it's in my data center or in the cloud or in a container, whether it's Windows or Unix, Linux. The data platform has to run where my platform is. It has to run where my IT organization lives. On the functionality side, AI and machine learning is becoming more and more important. That, we're still a little bit in the hype cycle on this, but there are organizations who are taking real advantage of machine learning and AI to glean insight and do things with their business that they could never do before. And we'll get into some examples of those when we get to it. Access to BI tools is important. As I said before, collecting data in and of itself does not add a lot of value. Gleaning information from that data does have value. So, whether I store a megabyte of data or a petabyte of data, if I can't access it, then it's really just passive storage. It's not adding to my business. So I need to have the tools that give my end users access to the data and access commensurate to their maturity level. So if it's just a knowledge worker that just needs to see their data, they need a tool for that. If they're a data scientist that's going to be doing really complex evaluations and experimentation with data, they need their tools to work for them. We can't have a single tool that will make both of those users happy, so it has to be the right suite of tools. We need to have access to unstructured data. One of the things that the Internet of Things, and I'm not going to talk a lot about IoT, but one of the things that has become much more prevalent in the IoT world is the presence of unstructured data. That is data not stored in nice structured tables in a relational database. So whether it's sensor data or telemetry data, PLC systems in machines on the factory floor writing to files that are being dumped, streamed into file shares. There's information in that unstructured data that becomes important in my business, but as we'll talk about later, a relational database is not the right tool to store unstructured data. So what is the right tool and how do we access it? And that goes with what I call specialized data processing. So think of things like hierarchies or graphs. Again, something that may be important, but something that relational databases traditionally do not do well. So how do I get that functionality into my data platform without relying just on traditional old relational databases? So we're going to go in and we're going to delve into all of these in detail in the 5 principles. Now, the other thing I need to stress with the modern data platform is that it is not a single tool. There is no one piece of technology that will give you a modern data platform. It's really a combination of things, and this is not, a modern data platform does not have to have every box here, but this is just to give you an example. So I may have lots of relational databases that have my operational data stores in them. So all of my line of business apps, my POS, my CRM, all of that information is all structured in nice relational databases. But then I've got a bunch of unstructured data as well. When it comes time to pull that data together so that I can see across silos and I can see cleaned and rationalized data, I may require a data warehouse. Now, data warehouses are very useful for pulling data from multiple sources, but they are relational data stores traditionally, which means I need to do ETL, extract, transform, and load. I need to have a schema that I've decided ahead of time. That schema says these are the things that I am going to store, and this is how I'm going to store them. So I need to decide in a traditional relational data warehouse up front what I'm going to store before I store it. With unstructured data, that can be very hard to do. So we have the concept of the data lake. The data lake is a large unstructured data store, which allows me to load data without having the schema defined up front. Now, we still need the schema when we pull the data out, but we can load everything and then go in afterwards and try to impose some kind of schema on top of it. In fact, we can impose multiple schemas on the data if we want to. The data lake can be accessed directly. The data lake could actually be a source for the data warehouse. So there may be pieces of information in that unstructured data that I'm always going to pull and always going to link back to something in the data warehouse. I can actually use the data lake as an ETL source for my warehouse. Or I can put something like a Hadoop system on top of it. The data warehouse becomes the data lake becomes a storage layer. The Hadoop or Spark system becomes the processing layer, and then my my front-end tools can talk to either of those. So what's important in this slide is to get the concept aside that it is not one tool for everything, but it's the right tool for the right job. And the technology needed to create the modern data platform is whatever I need based on the business requirement I'm trying to meet. And one of the nice things with the Microsoft technology stack specifically is that all of these can be included using the stack as it exists today. Now, Microsoft recently has rebranded this the Modern Data Estate. I'm not crazy about estate, but I thought I'd leave it in to compare and contrast. The reason I call it a data estate is that it spans a very large area, and it spans operational, warehousing, and lakes, and that can be both on-premises or in the cloud, or in both at the same time. So we can put the data where we want it so put the right data in the right place for the right reason. We're not locked into any one piece of technology, but we can choose what makes sense. But we can build a common security layer across everything. So whether data is on premises or in the Azure cloud, whether it's in a SQL Server or an Azure Data Lake or an Azure Data Warehouse. I can have single sign-in. I can have easily movement of data from one piece to the next, and some of that may be sitting on premises and some of it may be sitting in the cloud. And it really becomes putting things where they make the most sense. And these really are the 5 pillars we're talking about today. So platform, performance, security, and all the rest. So BI so let's start with security and compliance. Amanda, are there any questions before we move on?
Nope, not at this moment.
Okay. If anything comes up, please do feel free to put it in the chat window when we'll get to it. So security and compliance is a piece that I talk about a lot. And really, security and compliance covers 3 things. It covers how I control access to data, how I protect my data both in motion and at rest, and how do I detect when breaches happen. One of the interesting changes in the way security analysts think about security is that it's not do what you have to do to make sure you're never breached. It's assume you're going to be breached and make sure you have a system that can quickly detect and can quickly deal with any breaches as they come up. And that's really just the world we live in right now. So one of the nice things with SQL Server as part of the modern data platform is that it covers all of these. So again, when I say SQL Server, I'm talking about both the on-premises and cloud versions. So we do have full Windows authentication there. We have row-level security. We have dynamic data masking. That allows me to give my users access to a table, but mask out certain fields so that they can't see the true value. So, you know, I may have a customer service reps that can go in and see customer records, but when they access the credit card number field in that customer record, they see all X's except for the last 2 digits of the credit card. So they can use those to verify, is this your card, but they can't actually see what the card number is. But then I can have it so that my financial people, when they go and look at that record, they see the unmasked value and they can actually go and get the credit card and process payment. There's a lot of encryption here. Transparent data encryption has been around for a while, but that allows me to back up both my data and my backup files at rest. So if I'm worried about data theft, particularly with backups, transparent data encryption allows me to encrypt everything right at the database level. Now, because SQL Server has so many features, it also has been recognized as having the lowest number of vulnerabilities. So this table on the right is the National Institute of Standards and Technology, NIST, has a study of reported vulnerabilities by year. This chart reflects the last 7 years of NIST data, and you can see that of all the major database vendors, Microsoft SQL Server has had by far the fewest number of reported vulnerabilities. And this is really a testament to 2 things. One, all of the security features that come out of the box, and again, there's no extra charge for any of these. Most vendors can do all of these, but a lot of them charge extra for these features. This is something that SQL just does natively. The other thing is that SQL Server is much easier to patch than most SQL servers. So whereas most Oracle implementations tend to be N-1, N-2 as far as their patching level, SQL Server databases industry-wide tend to be up to the current patching level. One last piece here, the advanced threat analytics that's mentioned at the top here. This is a new feature that's been added to Azure. There are some advanced security features going into Azure just because trust is so important with the cloud. It's still new and Microsoft is very concerned with this. this is an interesting tool. It actually applies certain machine learning algorithms to behaviors against a database to flag particular activities. So it's good at catching, for example, SQL injection attacks, where there's certain user behavior that indicates that an injection attack is happening, and it can raise that as a flag. So I can go and see whether the attack was successful or not, and I can fix things if they are the case. But it also does things like geographical awareness. So if a user logs in Toronto and then they log in Shanghai half an hour later, the system will say, hey, wait a minute, that doesn't look right to me. I'm going to flag that as a potential breach, and I'm going to notify administrators. So this is actually a very useful tool. Now, Always Encrypted is an interesting one. And Always Encrypted, a second here. Here we go. Always Encrypted is a piece of technology that showed up in SQL Server 2016. It's in 2017 as well. What this does is it allows me to move encryption from the database to the client. So all of the data that gets stored in the database is stored encrypted. All of the data that goes across the wire is encrypted. The only place it's unencrypted is on the actual client application itself. So in this case here, my client has this enhanced SQL Server library. It makes a query. You'll notice that on the database side, all credit card numbers are stored as hashes. But when that record comes back to the client and the client runs through this library, it actually decrypts the hash and presents the actual unencrypted value back to the user in the application. Now, the only time that data is unencrypted is when it's sitting on the client PC. From the minute it leaves the client till the minute it comes back, it's encrypted the entire time. In fact, all SQL Server sees is the clear text of the hash itself. So very interesting piece of technology. And this also works between on-premises and cloud. So if I have apps on-prem that are running in the cloud, I can turn on Always Encrypted, and I never have to worry about my data being stored in the cloud and being stolen or decrypted from the cloud. And I never have to worry about data moving in and out of the cloud, that every time it leaves the client, it's encrypted. Now, one of the pieces that I talk to my customers a lot about security is actually support. Now, I call this out for a specific reason. If you are still running SQL 2005 in your environment, you are already out of extended support. So Microsoft actually will not support you at all for SQL 2005. If you are running 2008 or 2008 R2, you will be out of support in about a year and a half from now. And for the other versions, you're good up till about 2022 or 2024. What does out of support mean? Well, first of all, out of support means no more updates for anything, including security. So if a vulnerability is detected for SQL 2005 and that vulnerability is reported to Microsoft, Microsoft will do nothing about it because there is no longer a development team working on this code base. Which means your costs go up because now all security falls on you. If something happens, if there's an exploit or a breach, you are wholly on the hook for it, which means you have to tighten your firewall rules, you have to really lock down your SQL 2005 boxes, or you are opening yourself up to risk. Not just risk, if you have any kind of compliance requirements, there is a very good chance that that compliance will include support from vendor as a requirement for compliance, which means you cannot have anything PCI compliant running on SQL 2005, for example, or HIPAA compliant, or ISO compliant. All of these compliance standards have vendor support for security as a pillar. Without that, you fail an audit. So if you have business compliance requirements and you are running 2005, I would go take a look right now. You are probably out of compliance. Now, compliance is something Microsoft really cares a lot about. And again, for Azure, Microsoft is very concerned about building trust and getting businesses to adopt their cloud. So they have worked really hard to make sure that Azure, the SQL Server running in Azure, meets all of the main compliance requirements, including PCI for credit card processing, including SOC 1, 2, and 3, including ISO, including HIPAA for healthcare, FedRAMP for the federal government. All of these, most of the main European compliance requirements. So a lot of these are covered. So, and there's more and more being added all the time. So one of the nice things with the Azure SQL Database Service, the platform as a service version of SQL Server, is that Microsoft does all the patching for you. So every time you use that service, you are in fact always at the most current level, and there's no upgrades required to get you there. Just before I go on, Amanda, is there any questions waiting?
Nope, not right now.
Okay. So let's talk about platform. Now, up until SQL 2017, there really was only one option for platform, and that is Windows. And there were organizations that were interested in SQL Server, but they were Linux shops, or they did everything in containers, or they did not want to run Windows even though they were interested in SQL Server. Well, with 2017, one of the biggest changes is that SQL Server 2017 will run on Linux. It'll run on Red Hat, it'll run on SUSE and Ubuntu. It can be containerized in Docker or Kubernetes in both Windows and Unix forms, which means I can now run SQL Server on whatever platform my organization is running. If you are a Unix shop, SQL Server is now a viable option for you. So if you, we're talking to a number of clients now that are running Oracle on because they don't want to go to Windows. Oracle was the only real enterprise choice, but Oracle is quite expensive, and now they're looking at SQL Server as a lower cost way of getting the same high enterprise features running on Linux. So this is now something that we can discuss with customers. High availability becomes important, and high availability regardless of platform. So SQL Server out of the box has something called SQL Server Always On, and Always On is the name for a series of technologies used for high availability. The newer one, the Always On availability groups also don't require shared disk anymore. So I can have true high availability between SQL Server instances where I don't have to have shared disks. So they can be on different ends of the data center or even in different data centers if I have a fast enough pipe between them. But I don't have to start playing with iSCSI and all the storage gymnastics that I had to do to make traditional clusters work. Now, those replicas can be synchronous or asynchronous. So if I have, very often we'll set up a 3-node availability group. 2 nodes will be local to each other. They will be synchronous, so that minimizes data loss to the transaction level. And then I'll have a 3rd node somewhere else, usually across a WAN, that is asynchronous. So it's not impacting performance. It's giving me geographical redundancy. There is a little bit of a risk of data loss, but that really depends on how fast the pipe between the nodes is. I can also make my secondaries readable, and in SQL 2017, I can also load balance between my readable secondaries, which means I can have all of my read writes and updates going in a primary node, but I can have all my reports running off a secondary node, so I don't get contention between a whole bunch of transactions flying into a system and reports pulling off of that system, but that the replicas are always in sync with the primary node. So it's very useful technology. You also, as we said with platform, you have an option to put things anywhere. So you can still run things on physical machines. Now, I will be honest, it has been a long time since I have installed SQL Server on a physical box. In fact, most of what I'm doing is migrating physical SQL servers onto virtual SQL servers. Most of our customers are running either Hyper-V or VMware, and SQL Server works well in either. So the virtualization technology has come a long way. SQL Server virtually runs almost as well as it does on physical boxes. The only cases I would see for creating a physical SQL Server is for really large high-performance systems where I'm throwing lots of RAM and lots of processors and flash drives, flash storage, multiple partitions to build really big systems. And we still do support a few of those, but they're becoming more and more virtualized. You can also run SQL Server in infrastructure as a service, which is really just VMs in the cloud. So rather than having a virtual server that's on my own in my own environment, I have a virtual server in cloud. Or there is the Azure SQL Database Service, which is really platform as a service Azure. And again, this can be on-premise or in the cloud. It's all still SQL Server. Things all work the same across all of them, with a slight exception of PaaS that is not 100% feature compliant with the on-premise version, but it's getting closer every day. So when we talk about performance, we'll just pull one example out here specifically. SQL Server has full capabilities for in-memory, and that can be both in-memory column store indexes, but also in-memory OLTP, so actual in-memory transactional systems. So these can be updated dynamically, and the in-memory indexes update dynamically. Now, why this is so important is RAM is considerably, and considerably being in some cases, a factor of 10 or more faster than going back to spinning disk, even if you're going back to solid state. And what this allows me to do is it allows me to do things in memory that I could never do in a traditional relational database sitting on disk. The image here is actually trying to show one, a little not so obviously. Let's say that I have all of my point of sale systems pouring into a specific SQL Server database, and I have a big sales register table. Traditionally, if I wanted to analyze the sales, I would periodically, I would run an ETL job, I would grab those sales, I would fire them into some kind of warehouse or some kind of reporting system, and then I would do my reports because I didn't want to have the contention between complex reads and, the main purpose of this thing, which is to enter sales into the point of sale system. Now, if I just want to see how a store is doing day by day, having that lag is fine. But what if I actually have a process that's looking for fraudulent behavior in credit card transactions? Well, I don't want to run that a day later and find out all of the transactions that had been fraudulent. I want to know when it's happening so that I can cancel a transaction and I can notify security immediately. And I can have my desk reps actually seize cards or refuse to give the merchandise to the customer. I can notify in-store security, but I need to do that in real time. I can't go ETL and then find out a day later that, hey, that was a fraudulent transaction. In-memory allows me to do that. In-memory allows me to take my algorithms, whether they're written in R, Python, and actually run them against the live data without having the performance hit that I would take in a traditional database where things are flushing the disk and not running in memory. Functionality is a big one. Again, if I can't get useful information, then my data is not useful to me. Now, one of those places is in machine learning and artificial intelligence. So, you know, people hear AI and they're thinking Jarvis, but really AI can be something as simple as, you know, what rate should I charge this customer for insurance based on a whole bunch of criteria, including, you know, how they drive, a bunch of different algorithms applied to it. You know, it can be things like traffic analysis. It can be things like recommendations for, you know, recommendations engines. So people who bought product X also bought, you know, Y and Z, or you may like A, B, and C. These are all machine learning algorithms and artificial intelligence processes that make my business better, and things that human beings could not do because we just can't think fast enough to get them done. So any data platform that I want to use has to incorporate this, and Microsoft SQL Server does that natively. So SQL 2016 included support for R as a language for doing machine learning and writing the AI algorithms. 2017 includes Python support as well. So this is native functionality that is included with SQL Server, and one that you can take advantage of right away. SQL Server comes with powerful data modeling and analysis tools. So in this case, SQL Server Analysis Services. So we still have traditional analysis services, but SQL Server now has the newer tabular models, which are all running in memory. They are, in many cases, much more performant than traditional cubes. They also allow me to pull data from multiple sources into these cubes to allow for more complete analysis. Now, my counterpart, David Wickett, has done a session specifically on the BI side of things, so I refer you back to that to go deeper into these, but I just want to talk to some of these at a very high level. Again, getting the data out is one thing. Getting the data out in the format that my users need when they need it is another. And one of the changes that has really come up with 2016 and particularly 2017 is the ability to provide visualizations to any device, whether it's a computer, tablet, phone, iOS and Android devices. We want to make sure that the data goes to the user where they are, and SQL Server has all of these features built in natively, and that's they can be this is a native SQL feature and can hit multiple data sources, not just SQL Server. We also have the Power BI report server. This allows the amalgamation of both the self-service BI functionality of Power BI and more static enterprise reporting in a single tool that can surface both at the same time. And finally, extensibility. Extensibility is becoming more important because the nature of data is changing, so the tools that we use to access that data will change as well. And again, if all I have is relational databases, then that becomes my hammer, and then everything becomes a nail. If I have other tools and other options, then that makes my database more extensible. And Microsoft has included that, oddly enough, in the relational database itself. So the first of these is the ability to handle unstructured data. So the tool to use that is called Polybase. Polybase is a piece of technology that allows SQL Server to read unstructured data and present it back as if it was tabular data. So I may have a bunch of data sitting in a file share on premises or in a blob storage in Azure, and I can write a query using Polybase that says, okay, SQL Server over there, there's a whole bunch of flat files. In there, you're going to find data that looks like this. Go and get that data, stick it into the schema, and present it back as if this was a table. So let's just take a look at the example on the slide here. So I'm an insurance company. I'm being asked to generate quotes for my customers. But my data is not just sitting in my relational database. So I have some data there. I know how old the customer is. I know whether they're male or female. I know how long they've been a customer, or if they're a customer. If they're a customer, I can see how many claims they've had in X number of years. So there's lots of information I can glean just from my relational database. But then we have a bunch of customers who, to get a break in their insurance, have agreed to share telemetry data with us. Telemetry data streaming from their cars. And that streaming data is not going into the relational database. It's being fed into a flat file system with Hadoop running on top of it. Now, I need to be able to pull and join my relational data and my unstructured data in such a way that I can write a query that says this is what the quote you should offer this customer is. So with Polybase, I don't have to load the unstructured data into the SQL Server. I just read it from the files and I present it to SQL Server as if it was tabular. I then take my existing tables, I join them together so I can find the same customer both in the unstructured data and the structured data, and I can say, okay, based on age, gender, their existing policy history with us, and the fact that they never speed and they don't slam on the brakes at stop signs, we'll give them a quote of X. And Polybase allows me to blend that structured and unstructured data together. There's also support for JSON as well. JSON is a structured text language used very often by machine-generated files. We can store JSON as text in SQL Server, but SQL Server is able to read and understand the JSON scripts. SQL Server in 2017 has also brought support for graph databases. Now, graph databases have a very specialized purpose that is actually quite useful in specific situations, but something relational databases traditionally do not do well, and that is to handle complex relationships. So show me an individual and all of their friends and all of their friends' friends, because I want to understand you and everybody that sits in the circle around you. And then take all those individuals and map them to a particular behavior. So in SQL Server, in a relational database, traditionally that was very complex in recursive logic. It was really expensive from a performance standpoint. It was slow. If I could get the logic to work at all, it could take hours to get data back. With graph databases, the graphs understand the relationships. And so I can say, give me all records where X is related to Y is related to Z. And the graph understands the relationships, and it can very quickly pull all that data back. So I can find, customers who are members of this group, who are friends, or who are friends with members of someone in this group, and get those kinds of logical extensions that I could never really do with a relational database. So that really is my modern data platform. Again, regardless of what actual tools you use, having that common security layer, having that single sign-on, having the ability to protect data and monitor activity across all of my tools is key. Something like Polybase only works if my user can authenticate both to the relational database and to the flat files. Having relational databases tied to data lakes, tied to data warehouses, again, that requires a common security context that goes across all of them. Performance is key. If my users can't use the database, if it's not meeting their SLAs, then they're just not going to use the system, and there's no advantage to it. Having platform of choice, making sure that I can run my database and my data platforms wherever I want them, whether it's on-premise in the cloud, on bare metal, virtualized, on Windows, on Linux, making sure that I have the choice, making sure that I can use whatever languages I want. Can I write apps in Java? Can I write apps in Ruby? Can I write apps in Python? And SQL Server will support all of that. We need to make sure we have the functionality. Can I get the right data to the right user at the right time? And do I have the extensibility to use things like R or Python to bring in AI, to bring in machine learning, to bring in graph databases when I need them? So these are all considerations you need to have as you're modernizing your platform. Again, SQL Server and the Microsoft Data Stack is a great venue for this because all of those pillars are supported there. And certainly this is what we do as a business, and we're very happy to talk at any point with you about your organization and how you can start where you are and take things into a modern footing. We do a lot of health checks and just general consulting and everything right up to helping you get up there. So I hope you got some useful insight from here. Certainly, if this is something we can help you with, please do reach out to me. I'll put my contact information back up again. But we've got about 2 minutes left to the top of the hour, and if there's any other questions, I'll take them right now. Amanda, anything waiting?
Nothing waiting, but I wanted to thank everyone for joining our webinar today, and I will follow up with everyone, making sure you guys all get a copy of the webinar to watch when you need to, as well as a couple of our offerings. So yeah, thanks again for joining.
Thanks everyone, have a great day.